Well, hi, good morning. Thanks for joining me. I just finished shooting the video that you're going to watch next, and I realized as I finished it there was something I wanted to talk about the last video. So I'm doing this little piece to insert in the front of the video that's coming. What I wanted to talk about was the hum. In my last video I was trying to beat down the hum. I used a frequency spectrum analyzer looking for the 60 cycle hum, and in the middle of it what I ended up seeing was not so much 60 cycles, 120 cycle hum appeared on the display, and I didn't comment about that. I just let it go by. So this is one of those things that's bothered me pretty much all my life when I've been doing this kind of stuff since I've been a kid, and that is, am I hearing, when I hear a hum, am I hearing 60 or am I hearing 120? Now the fact is 60 is really quite low. 60 hertz would be hard for a speaker sitting on my bench to reproduce without an awful lot of power behind it. 120, and part of that is because our ears are getting pretty weak at 60. At least mine are. 120 though, I can hear that quite easily, and the speaker can reproduce it easily, and that's what we saw on the display. 120 hertz. Now why would that be? I got the radio plugged into 60 hertz, and yet I'm seeing 120. The reason is quite simple. There's a full wave rectifier inside the power supply, so it's rectifying both the upper half and the lower half, and in a sense bringing them both to the top. Kind of think of it that way, and at that point, and then that's what's being filtered and sent through the radio, with both the lower peak and the upper peak up at the top. You can hear 120 hertz, not 60. And so that's what was going on there, and I just didn't say anything about it. It was certainly rolling around in my head, but I was silent. But for me, that experience really clarified what it is that I'm hearing. Now I know better about the hums. I'm almost always hearing 120, I would think. Almost always. Even in the case of a single sided rectifier, maybe in a little tiny radio, I think if it produces a hum, it's probably still 120 that I'm hearing. So I'll leave it at that, and hope you enjoyed the video that's coming now. Well, hi, and thanks so much for joining me in my shop. I'm in the final stages on this radio, ready to do the final alignment, and hopefully that's it for this radio. So I'm set up now to do the IF alignment. That's a good place to start. I've got two signal generators going. I've got a sweep generator sweeping through the IF frequency. I've got a marker generator going also, so we can really precisely see where the IF frequency of 460 actually is. I've got my scope going, ready to show the sweep, and we'll also see the response shape. Well, at least that's what I hope will happen next. We'll see what happens, because my last 4 or 5 journeys into this shop have not gone the way I expected. Not that anything really terrible has happened. It's just unexpected things happen. That's about it. Okay, let's turn on the radio, which I should have had warming up for quite a while. I haven't yet. Let's get it warming up. I've had my equipment on for about a half an hour, making sure everything is stabilized. Now I'm feeding both signal generators into the antenna. The recommendation for doing the IF is to feed the IF successively, into a couple of grids on a couple of these tubes, in order to focus the whole thing right down on the actual stage you're interested in tuning up. Part of the reason for this is because the assumption is the radio is so far out of alignment they're going to have trouble even getting it going. Oh, here we go. Okay, we're already in trouble here with the noisy tube. Is it this one? Or is it this one? Okay, so I got well, it didn't even take 10 minutes. So I think what I'm going to do is I'm going to change both of these tubes. I'm going to take the originals out. I'm going to switch them both with alternate tubes before we do this alignment, because Yeah, that should muck everything up. Okay, let me get my... if I'm going to do that, then we better have the radio operating when I do this. So let me... I should fire in a regular radio signal into the antenna and have it coming out. We could tune in. You know what? I'm gonna I'm gonna hook up an antenna. Oh my gosh, going backwards. Okay, now the radio is silent at the moment, but it just when it's off camera, just hooking up the antenna, it went bop and went silent. So now we can figure out which one of these. I'm pretty sure it's this guy here.
You mean? Yep. The neighbors won't be the only ones.
Now, you know, it's not necessarily a problem with that tube. It's more likely just a problem with the tube contact. So when I change the tube to another one, will that really help? So here's another one, 6F6 metal tube. This is what I want to try. I think I'm going to run it through the tube tester first, though. Let's do that. Leave the radio running. Today's a special day. Today is the first day of a significant snowfall prediction here. Let's see if I can get a little better lighting on this. Could get 10 to 15 centimeters today. Yeah. That'll have to do. 6F6. Chart here, 6F6, there it is. 6.3, signal is number 2. Bias is, I can't see what I'm doing. Bias is 46H. 6H. 27345. 2, 7, 3, 4. 7, 3, 4, 5, 0610, 610, 34, meter sensitivity, F for the plate connection, 830 on the scale, so it should be coming up in this area here. There we go. See the scale. Okay, first check. It's going up a little bit on position 1. Good. 830 should come up to about there. Ooh-la-wee. There's a good one for me. Okay, so that guy's going to go in to the radio, which by now has heated up its glass version of this tube. So hot I dare not touch it. Power off. Take out this big guy here. It's not in there very good at all. Really, that my attempt to fix the contacts in the tube base hasn't gone very well. Let's see. This one goes in. Doesn't feel particularly good either. Okay, that's one tube. Let's give the radio play here. Of course, we're going to start it on the dim bulbs. So I've stuck another tube in. Seems fine. Yeah, let's see what we get. It's on full power now. Okay, let me wiggle the tube. I certainly don't want to touch it here. I don't want to touch the just a rule I have about, two hands, using two hands. That tape is my insulation there. Wow. Is it really that one tube, or am I moving another tube here? Well, although there's a lot of popping, it's operating consistently, even though it's popping at times when I move it. It's good enough the way it is. This will be my tube set going forward. It's going to go with the glass tube. Doesn't seem to be a problem with it. I just wanted to try putting in metal ones there. Very good. So now we're ready to go, I think. Let's listen to it.
Security needs? Who helps 75% of the world's Fortune 100 companies get their security right? The answer is obvious. I'm Rath, Country Manager for Optum Canada. We provide optimized and rationalized cybersecurity solutions with local resources.
Perfect.
Secures your security. Optum.
Antenna off. I'm still concerned that the AVC doesn't. The AVC doesn't. Okay, so this is the sweep going on. The sweep generator is not sweeping right now. And notice again, I am connecting these to the antenna, not really where you want it. Well, I shouldn't say that. Not necessarily the most powerful place to try to feed an IF signal into a radio. But we're going to try it on the basis that the radio is pretty well tuned anyway. So it should be very close. Now, if let's just pump in a 460 using this signal generator just to make sure the radio's going to do the right thing here. There it is. I can hear it already. Right on 460 according to this. So I'm going to turn that off. 460. I'm going to start the sweep generator going. So let's watch that happen. So the sweep that's on here right now is actually coming from the signal generator, not from the scope. Now what I'm going to do is I'm going to increase the output level of the sweep generator, which is, let me just double check its settings here. First of all, stop the sweep. So it's starting at, I want it to start at 440. I gotta just advance this a little bit here. I want that number to be 440 up there. Oh, that's as close as we're going to get. 440, and now the stop frequency should be 480. That's where I want it to be. This will put 460 in the middle of the sweep on the scope. Oh, that's right on. That's perfect. Okay, we'll turn on the sweep now. Go back and take a look at the scope. So what I want to do here, turn this brightness down a wee bit. There we go. So this is now sweeping. This is 440 hertz, and this is 480. 460 should be dead center. The scope is connected to the output of the detector. So as I advance the signal level from the sweep, we should see a hump form right here in the middle. I'll turn the volume up a little bit so we can hear this. I can still hear the other frequency generator. Okay. Well, I can still hear the radio signal. Let me tune it off here. You're not supposed to hear any of this. There's a quiet spot there. Okay, we're ready to go here. Advancing the output of the sweep generator. Okay, turn down the volume, up on the level. Beautiful. So it's not quite lined up dead center of the scope, but then what I've done here is not 100% reliable, which is why I want to bring in another signal now, which is the marker generator. And the way this will work is it doesn't exactly put a pip on here that you can move around. It causes interference with this, and when you get it lined up, well, you'll see there is a funny little blip, but it's not quite as clean and neat as we might want. Okay, so I'll bring this through 460 here. Okay, I didn't see a thing because I didn't get there yet. Here we go. This is what I was talking about. Okay, so I'm setting the marker generator to 460. That would be 460. Yeah, wow. Let me just make this a little more visible on the... Very tricky on the camera to do this. Okay, you're gonna have to put up with a bit of a faint look here. Come on. There. It's barely visible for me, but it looks pretty good for you. So we're looking in here and we're seeing let me turn down the level here on the marker generator. Now I'll move it back and forth. Okay, so see that little thing going through the peak? So if I want to measure the peak, I would set it right there, and then I would look over at the frequency counter. Dead on. 460 is here, not where the line is. So that's what that's telling me. So this is telling me that the alignment is good. At least it's good in terms of being on frequency. Now we're going to adjust the alignment a bit, and this is actually quite difficult to do with the sweep generator. It's a little easier with a marker generator alone. We could try that. So I'm just looking for a alignment tool here that I can use successfully. I think this guy will work. Okay, so let's see if I can just make a quick adjustment here. Bear with me. What I'm going to do is I'm going to put that right on the screen here. Put it in the lower right corner. Like that. Okay. So we're starting with this one here. This is the second IF. Primary in the bottom, I'm pretty sure. I read. Trying to get my tool to engage here. There it is. Okay. Now, just watching the display. In fact, let me get the marker out of there. I'm not trying to move it now, or trying to make it bigger. That's moving it. Notice the shape of it, eh? So this is nice and round here, broad. If I go over here, it's a little sharper. We do want it to stay at 460. So we'll adjust this to force this point to stay where it is. Bang my camera there. Can anybody speak Finnish? I can't. Now, get the tool into my overly large tool here onto the okay, it's in. Now we're ready. So I'm watching that screen again. And you know what? I'm not going to be able to turn it. Ooh, this is so stiff. So this is a narrow tool. You don't get much leverage on it. Though if your sliding stuff is easy to slide, this is fine. But if it turns out it's really hard to turn that screw, something like this, like you can't get any grip. I need some width. I need some width. I need some power. I also like the, as I've said many times, I like the stiff metal shaft when I do this. I don't like the twisty, flexible plastic ones. They just, especially if you get into a stiff situation like this. Now I gotta put the screwdriver in here without seeing what I'm doing. I'm listening to it. Wait, look at what's happening here. So this is my finger. This is the screwdriver without my finger touching it. But I'm holding onto the shank like this, so I'm capacitively connected to it. This is not going to be, it's not going to work well, I don't think. Let's get it in there. Okay, believe it or not, I managed to get it engaged there. Oh, it came out. Okay, this is really tough to do here. Let's make it a little easier on me. Now that's in, but it's disturbed the circuit to some degree. Let's see what we got here. A lot of these IFs have two peaks too. Okay, so that's getting small. For crying out loud. I'm going to try another tool here. Try this one. It's still got the flexi in it, but this isn't going to be any better. It's got a little bit of a grippy thing. Let's try this. This isn't likely to slip out so easily. There. Okay, we're ready to go again. I'm watching the scope. See, now what would that do on the voltmeter? Would that be increasing the reading on the voltmeter? Since we're not listening to a radio station, we can't really tell what's going on here. It's changing its shape over here. This shape, perhaps the proper shape, is not supposed to be perfectly uniform on my screen here because you know, there's a logarithmic sort of thing happening here. Yes or no? I don't know. The sweep is set for non-logarithmic sweep, which is why I can put 440 here, 40 there, and get 460 in the middle. On logarithmic, it wouldn't work that way, but I don't know. See, this, every time I've done this, I've kind of been left wondering, gee, I end up putting a voltmeter on. Yeah, that sounds like a really good idea. Voltmeter on what? Voltmeter on the speaker. lights on properly. Now, perhaps using a voltmeter with a sweep generator is not effective. I'm not sure what the story is with that. Let's turn up the volume here and see if we get the meter. Oh yeah. Yeah, I'm not sure at all. No, normally you're doing this with a single tone. We'll try it in a moment. As opposed to, I'm going to stick my hand right in front of that meter, aren't I? Maybe not. Maybe I'll go under it. Yeah. Okay, so I'm watching the meter now. So this is where the meter would take us, to this spot. Now let me look at what we got on the scope and move it around. I would guess what the meter's actually responding to is kind of the volume inside this space here. Either that or it's responding to the absolute peak, but I don't think it is, because I think I can reduce the peak and increase the meter. So reduce the peak. Yeah, the meter peak is right here. Get the peak to come down just a hair more. So let's go with the meter. Okay, meter's peaked. Let's go underneath. Do the primary of that again. Now the difference in the operation of the radio has got to be microscopic at this point here. Oh, look at that. So what's the meter doing? Okay, meter peak. That's the peak. Now, I'm looking at the scope now. I can only look at one thing at a time. Actually, you know what? I can do like you. If I look at my TV monitor, I can watch polls. Well, it seems to be right in here. If you listen to the sound coming out of the speaker, the hum, I know it's just a hum, but listening to it, there's a big difference here. Now, would that be the same kind of difference on a radio station? That's a really good question. Let's find out. Okay, I can leave everything just as it is. Stick the antenna back on. I have to tune the radio. Let me tune the radio now. Oh my gosh. Well, okay, so what's probably happening here is I'm changing how much of the IF frequency can get in through the antenna. It's probably what's happening here. So I'm just tuning it a bit here. That being the case, then you would expect the tuning to be closest to 450, at the bottom of the band. That's where it is. Radio's tuned right to the bottom of the band. So that's what's happening there. I'm just patting down the input. So I believe. So we'll still put on the antenna and listen. You know, I do like to experiment a lot. In case you haven't noticed. It's really where the fun is, I think. Some of the fun. Take off the signal generators here. think I can leave the grounds connected. Ooh. Don't fall into the radio. I just want to disturb as little as possible here. Okay, we'll bring up the antenna. Assuming the ground connection. Wow. You can't see that, but that clip lead, you know how you let go of a clip lead and it has a mind of its own at first. It snapped right into the radio. Luckily, there we go. Clip lead insulation saved us there. Okay, antenna's on. Volume up a bit. Nothing.
Because of earlier problems, westbound 407 from Airport Road to approaching Bramalea Road, we had a collision that fell on the shoulder. Debris moved over as well. Southbound 400 approaching Highway 89, some tire debris in the center lane. Southbound 404 south of Stouffville Road, we had some debris in the center lanes there as well. We have a serious accident in the intersection of Birch Mountain and Ellesmere, so that's closed all four ways in a good area to avoid.
Okay, that sounds tuned to the center. Now I'm going to move this a little bit. We'll listen.
Lease a 2019 Lexus RX 350 for as low as 2.9% APR with delivery credits of $1,000. Visit your Lexus dealer for details. From the 680 News Traffic Center, I'm Lena Volka.
It's quite a bit.
The Smart Choice with F-150. During the Ford Smart Choice event, get 0% financing for 72 months.
Okay, if I were to tune this by ear.
F-150. Hurry, it all ends November 30th. Details at findyourford.ca. Hey, how about a road trip?
How about a
I would pick that spot
Or we
there.
could go to the movies.
Or we could play video games.
Families don't always agree, but they do agree on pizza for dinner.
They do, eh? Pizza for dinner. So now hook this guy back up. Where did we end up? Put this back in. Okay. Now we're a little bit familiar with the buzzing sound here. So what I'm hearing when I listen to this, when it's tuned over here, I hear a slight drop in the volume, and the tonal quality to me sounds like less harmonics are in the sound. The sound, it's a kind of a sharp sound anyway, but it sounds sharper as I go. Oh, wrong way, let's go this way. Now, my ear tuning the radio, the station, like this spot. The wave shape looks best over here. Here. So I guess we could think of those slopes as the sidebands that are making it through. How much of the sidebands are making it through? You kind of want it to be about 10, well, maybe not 10 kilohertz. Good AM station, you're going to hear 5 kilohertz coming out of it. So this could be a little sharper yet, perhaps. Let me put that right on the line here. I notice we've moved over to here. I'll bet you my sweep generator has changed a little bit. I notice it does drift. So let's double check that just to be sure. Be sure of everything. Stop the sweep. Start frequency is 438. See, it's dropped a bit. Take it back up. You're going to do a high precision alignment. You have to face all these little niggly problems. And this should be 480. Really don't like adjusting this stuff in the middle of doing these kinds of things, but here we are. 480. Wow. It's hard to be that precise with this. That's close enough. Back to sweeping. And didn't do too much to the display. Oh, we have to center the display now. Perfectly in the middle. Assuming there's no cutoff at the start, that my scope manages to sweep right at 440 there. So we see we're not at 460 according to this. Well, that could indicate that doing this on my scope, I have to make some kind of allowance over here. Let's measure the, let's see the 460 with the other signal generator here. So that's where it's set. I'd say the little jiggly thing kind of right in the middle here. And we're, if anything, we're a touch high, maybe 461. Now, what are we doing about that meter? Let me move this. Let's stop the sweep. Now you're just hearing a tone from this generator here. Now, this is a classic way to align the set. Frequency over here, if I just tip the camera a bit, you can see it on the... That frequency counter's a touch high, so it's actually, if it says 460, it's actually 461, 462. I can hear the radio station coming out of there. That's probably why I hear two tones. I hear clearly the tone from the signal generator. I hear another one. Let's tune this off. Yeah, see the other one moving? I mean, you don't see it, you hear it? Okay, we'll just get rid of that. Heterodyne. Okay, now the objective is get this meter up as high as it can go. This is really this is the way I feel most comfortable doing this, to be honest with you. This fairly simple way. Okay, here we go, I'm watching the meter now. And I'm turning the wrong select. Okay, so I switched transformers by accident. That didn't help. Let's go down to the proper one. Here we go. So that was not dead on according to... it gives you a good feeling when you use a meter like that, because you can really see it. In fact, I would never use a digital meter for doing this kind of thing. You cannot get a feel for it. And you can never forget the fact that you're fighting, let's put this way, with the AVC, especially if you've got a fairly high signal level coming in. That up and down on the meter is my finger touching the, there it is, we're in. Okay, watch that meter again. Really not much of anything. Same thing on the scope there. It really wasn't much of anything. We're going to go ahead and we're going to do the other transformer right away. I think the main thing is to get them both tuned to the same frequency. Okay, watching now on the meter. I did this earlier, and it's like despite all the change, despite all the changes I made to the radio, it hasn't thrown this off very much. There we go. Get my hand away. Okay, here we go. Watching that meter now. Wow, this guy. I need the strength of Samson to turn this thing. Oops, turning that way. There we go. So you can see the peak there. I'm not sure why that was so hard at first. So that's peaked. And I already did it down here, didn't I? Maybe not. Yeah, I did. So there we are. So I think this guy is tuned right up now. Let's take that one off. We'll put on the sweep again. Don't need to listen to it. So you get a beautiful shape here, I think. And let's see, if this is 460 right in the middle, and this is 440, there's 20. 5, so 20 divided by 5 sections is 4. Would that be 400 hertz? 4,000 hertz. Wait a minute, hold on, losing my head. Start again. 60, 40, so there's 20 kilohertz in here. 20 kilohertz divided into 5 pieces. Four kilohertz. So if we try to pick the 3 dB down point on this curve, which is a half power point, it's pretty much where this line is crossing here. So then we measure over this way from the middle. It's roughly, very roughly 1 division. And 1 division I said was how much? So this is 1 division is 4 kilohertz. So the bandwidth here, you could say 4 or 8, depending upon what you're talking about. What's it supposed to be? I don't know. But the wider you make this, the more signal, the broader, the more sidebands, the more of the sideband it brings in and amplifies. And the effect of that is hearing more and more treble, but you run the risk of starting to hear the next station over until you lose the selectivity. And as for sensitivity, yeah, I think if you broaden this out, you'll probably reduce the peak and reduce the sensitivity a little bit. But these radios usually have sensitivity to spare, especially if your intention is to tune in a powerful signal, which is, you know, with this radio I'm not going to be hunting down long distance AM radio stations. In fact, face it, this radio is going to sit on a shelf along with some other radios. Well, that's the IF. I don't think I can beat it any better than that. So if you want to carry on here and do the AM band, well, I got to think about that. This might be the end of this video, and maybe I'll do the next portion on another video. So hey, thanks a lot for watching. See you on the next one. Whatever it is I do on the next one.